Welcome back. Announcements first. Some people have asked about the midterm, so I just want to share with you midterm exam. I am scheduling the exam for Wednesday, March 10. So you still have plenty of time to prepare. It's going to include everything from lecture 2 to the lecture before the exam. My plan for the lecture before Monday, March 8th, is going to be to do a full review, give you hints about possible questions and so on. But for now, please put in your schedule, in your agenda, midterm exam, March the 10th. Good. And also, you have a quiz. The quiz number 4 is going to open by the end of the lecture, and you have all day until midnight. Basically, everything about principles. And I am talking about object-oriented, abstraction, encapsulation, polymorphism, concurrency, and so on. And also regarding programming, dry, keys, readability. So everything that we review in the previous week, principles for programming, for design, your quiz today. Multiple choice questions, 10 questions as usual, and you have 20 minutes. So good luck with that. Moving forward for today, what we have reviewed is how to connect classes. What we review is, I have my requirements. From that, I select my classes. And when I have a bunch of classes, I need to connect them to create a system. Now, in order to connect them, I have these relationships that by now you should understand 100%. And well, they are different. Each of them means something. Each of them is programmed in some particular way. Which one to use? As you know, and hopefully your assignment helped you, there are several different ways in which you can use these connections, and you're going to get a solution that works. These connections are like trying to do a program using zeros and ones. Obviously, you can do a program with zeros and ones. It's not your best option. Somehow, you're going to do something that could be similar or completely different to someone else. And both solutions are going to do something that solves the requirements. The reality is, instead of zeros and ones, you use a high-level programming language. Instead of zeros and ones, you use conditions, loops, methods. Moreover, you define classes and you define objects. When we talk about programming, it's kind of pretty clear that classes have methods, loops and conditions translate to zeros and ones. Different levels of abstraction. When we talk about design, this relationship between my classes, they are the equivalent to these zeros and ones. You do not do a class diagram. You do not do a software. You're working directly with classes and composition, realization, association, and so on. They are used the zeros and ones for something else, for the high level thing. The high level thing, patterns. In particular, patterns for the design and patterns for the architecture. If I show you an analogy. The patterns for the architecture is like your classes and your objects. What they have inside are design patterns. The design patterns are like your condition loops and instructions. What they have inside, what they are, is one step before translating your code to zeros and ones. These one have these ones, and these ones are going to use these relationships. And as you know, from here, you can move to the source code. Levels of abstraction. You know how to do the code. Now you know how to use this individually. What we need to do is review these guys. Combinations of association, composition, aggregation, and so on that already exist, just like the loops and the methods from the libraries that we can use and solve a problem without go into the details. Patterns. Key idea. You're going to create a piece of software. When you're going to create a software, option number one for the programmers, for the coders, start from scratch. No one do that. If you're going to create a piece of software, what you're going to do is something that the Lego approach. You're going to find things like the Lego blocks, and you're going to put them together to create what you need. You do not start from scratch trying to create something when you already have things that you can put together and get your solution. Two reasons. Number one, because resources, time or money, whatever. Using this is cheaper, faster, whatever is your requirement, than start from scratch. But also quality. The quality of something that you do just putting together components, elements, is going to be better than the quality of something that you start from scratch. Depending on your experience, but in general, the average, doing this have better possibilities to have quality that use randomly trusting in the skills of one specific programmer. Okay, what we need to do is to learn which blocks do we have available to create software. And I am not talking yet about components, libraries. What I want to talk is about the solutions in the abstract level. Ways to put together classes and connection, relationship between classes. So patterns. If we talk about the patterns in the Lego, there are basically two patterns. One for the input and one for the output. And you always know how to put together two blocks of this because everyone knows how the inputs are going to be and how the outputs are going to look like. And just because they match, everything can be put together with anything else. For the software we have a lot more than this. More. Think about this. Patterns, solutions that any developer should know, could know. At least the basic, the fundamentals, 23. 23 patterns, 23 solutions, just like the Lego blocks, for common problems that you're going to find every single time that you're trying to create a new piece of software. Those 23, the basic one, usually if you search for them, they are going to be label the gang of four pattern or the GOF patterns. Gang of four. Yeah, there are four people that propose those patterns. So the gang of four, the four friends, so something like that. For people defining these patterns, there is a book that basically what the book do is to describe those 23 patterns. Highly recommended for you if you're planning to continue with software. Very good lecture. It's a small book. Basically, the book describes in detail 23 patterns. We're not going to review here the 23, but at least I am going to give you an idea of some of them. A selected group of them. The authors of the book, the authors of the patterns. Patterns. Every single time that I mention a pattern, I am talking about a solution for a problem. A solution for a problem from the point of view of the design. A solution for a problem from the point of view of design. I am talking about a small class diagram. 23 class diagrams that describe 23 things that you can combine in the class diagram for the full project. And together, what you have is these small Lego blocks that together give you the solution of whatever you want to do. Patterns, blocks. The blocks that we're talking about here, class diagrams, design. We're not talking about libraries, not yet. It's just blocks for the class diagram, blocks for the design. Good? Builder, one of the patterns that we're going to review is the builder, yes. These 23 patterns, 23 solutions, are organized in three categories, three groups. So if you make a counting of the different names that I have here, there are 23 names for the 23 patterns, but they are in three groups. There are patterns for creating things. They are called creational patterns. What do we create in a piece of software? Create what? Well, you can do that with objects. Creation. You have classes, and the reason because you have classes is because you want to create objects from those classes. So these patterns are going to tell you what is the best way to create objects. Let me be clear. If you think about creating objects, what do you do to create an object? And for the naive programmer is, you want to create an object? Use the operator new. Yeah, but where did you put the new? Inside of a constructor? Inside of a class? Any method is okay to have the news? Do you have specific classes that do the news? Or it's okay to put a new in any place that I need it? It's a very bad idea to use the new in every single place. A really bad idea. Because if you're creating objects in every single class, every class can create another object, just like we did with our previous assignment. That is very hard to modify and maintain. Okay, you get the idea. Option number one, centralize. In some particular place, centralized function or class that one should be the responsible for do the news. All the news are going to happen in that particular place, centralization. We're going to review that is a very good solution in some cases, not for everything. And you know what? That particular solution is going to have a name. when you centralize the place in which you create your objects, that central thing, that place in which you do the news, is called a factory. And it could be a class, or it could be a method. It could be an abstract factory, or it could be a factory method. We need to review the details, but yeah, a place in which you do the news, a place in which you create the objects, that could be a factory. And it's just one of the patterns. Now, how many objects do you create from a class? If I create a class, a student or professor or homework, assignment, quiz, whatever, usually how many objects you create from one class? Usually as many as you want. If I create a class professor, how many professors I am going to create? As many as you need. How many students? As many as you need. But you know what? There are some scenarios in which you only want to create one. You only want to be able to create one object. Moreover, you want to do the class, but you want to be sure that your friend that is in your team is going to use your class only one time. And you have two options. Option number one, to tell your friend, please use this class only one time. And obviously that is not going to work because your friend is not going to listen to you. The other option is to use the pattern. And by using the pattern, what is going to happen is if your friend tries to create more than one object, the program is not going to compile. And that is better than asking for the favor. The pattern that can help us to define that only one object can be created, singleton. And remember, every single one of these names here is the name for a class diagram. And if the name of a class diagram, that means is one name connected with the class diagram, connected with source code that I can use. Factories, singletons, prototypes, builders. We need to review these guys. At least some of them, patterns to create objects. A different one, behavior, patterns of behavior. Behavior of what? Objects. Common behaviors for objects. Do you remember our Pac-Man video game? Do you remember that you have the Pac-Man here? You have the ghost. And do you remember that the ghost need to know the position of the Pac-Man, this X and Y coordinate of the Pac-Man, in order to do something? It's just like that. The ghost need to know where the Pac-Man is. The ghost, this object, need to access information in this other object. Two objects and one need information that is encapsulated in the other. That have a name. It's a common problem in programming. Several different times in several different projects, like in the Pac-Man, you need one class having access to the data in another one. One object having access to the data in another object. That is a behavior. And have a fancy name. Observe. One object, the ghost, need to observe the Pac-Man. Observe, get information about something, the X and Y coordinates. Sharing information between two classes, a common problem with a common solution. The common solution have a name, observer. And for that, there is a class diagram. And that class diagram, source code that we can reuse. Other common behaviors, strategies, chain of responsibilities, iterators, mediators. We need to talk about them. What is the problem that they solve? And the class diagram and the source code. Similar with the third category, structure. The structure of what? classes and objects. You will notice we can decorate objects. We can create facades, bridges, adapters. Just by reading the names, hopefully you notice that we're talking about different ways of connecting two objects. I have these two objects, they need to be together. I can create a bridge between them so they are connected. Oh, I need to connect these two. Maybe I need something in the middle, like an adapter, something that is going to help me to connect this one with this one, maybe because by default they are not compatible. Wait, maybe I can decorate this one just by put this one inside of this one, and this is the decoration. This is the original one. The structure, how they are connected, related. Creation, behavior, and structure of objects. And I have different solutions about how to do those things. Which solution to choose? Depending on the problem that I have. The good news is any of these solutions have a class diagram, any of these solutions have source code, and any of these solutions have been tested before by other developers. If I use any of these solutions, it's not something like reinventing the wheel. It's not something like, oh, I just have this great idea about solving this problem in this way, and let's see if this works. This option, like the Lego blocks, they are going to work. And if I use several of these in a system, more of this that I use, easy to understand the solution, easy to test. That is the goal of the patterns. Make sense? And hopefully, yes. Now, the theoretical background is like, good. My goal, if I give you a class diagram, usually it's just like giving you source code and asking you to understand the source code. Asking you to understand the class diagram is start reading the diagram, figuring out the different classes, and check the different connections, and somehow try to guess why here is composition, aggregation, realization, inheritance, and how all of that things merge to solve the problem. Hopefully, if you read the diagram for the Pac-Man and you create your game following the same idea, it was easy to understand your game, your diagram, because it was the second time that you implement something similar. But when you read a class diagram used online for a system that you do not have previous experience, just starting from scratch is not an easy task. It's exactly the same that open source code that is not yours. The goal of the patterns is what if you can identify that between two classes, there is an observer pattern there. Therefore, you know that whatever this class is doing and whatever this class is doing, I have no idea, I don't care, but A is observing B. Okay, this class needs information that this class have. This one is the source of the information, but this one is using that information. What if I told you that this B is a factory? Okay, that B, I do not know what it's doing, but in that B, there are a lot of news. New operator, because here a lot of objects are being created. What if I told you that there is another class C that is also observing B? So I have two classes, and those two are interested in this factory that is just creating new objects of a particular class. What if I told you that inside of this factory, I am creating a particular object X, boxes, but that particular object is being decorated with a particular element W. What if I told you that I have a factory? The factory is creating objects X, but they are decorated with something W, and there is a class A and a class C that are interested in checking, observing every single time that an object X with a decoration W is created. What I am sharing with you is a story of, okay, something is being created there, someone is interested in that, and what is being created there is this element that is the core with this decoration there. Decoration, factory, observing, all those words encapsulate complex things because you're going to look at the diagrams. It's not just one connection, like in this picture. The connections are going to be complex, are going to involve composition, association, aggregation. It's going to involve not one class, but usually a family of classes. But when you describe the solution, when you describe what is happening, the level of abstraction allows you to understand better the problem. It's just like when you do a program, and in your program you do a loop, and inside of that loop you put a condition. Explain a loop and a condition is a lot easier than trying to explain zeros and ones that are equivalent to exactly the same. Going up in the abstraction. Understanding the meaning of every single one of these words give you options to talk with other developers and to say, hey, you, my friend, we're in the same team. I am going to do this class A, you're going to do this class B, and we're going to connect them with the observer. Done. Hopefully we both understand what is the meaning of observer, and therefore we both understand what we need to do in our class A or in our class B. And they are just going to be connected without any problem. Main problem that we have when we work in a team, integration. It's very easy to split the work. It's very easy for you to create one class and for me to create another one. The problem? Put the classes together. Be sure that when you finish and when I finish, our classes are going to be able to connect. And for that is that we have the patterns. The patterns describe connections for different problems, like the ones that I described before. So we need to review these guys, not all of them, but we're going to review at least 2 from each category to give you an idea about what happened. The first one, maybe the most common one, the observer. And remember, observer, behavioral pattern. Behavioral pattern. Let's see. The idea is very simple, as I described before. I have an object, and that object has something that other objects need. Before I tell you one class, another class, an object from this class, and from this class, it could be one object or several, like in the picture, but there is one that have the information, and there are others, one or more, that need the information. If you want to think about it, this is the Pac-Man, and we have, at least in our example, 4 ghosts. And the 4 ghosts were interested in the Pac-Man. Now, interested in the Pac-Man, they were interested in the X and Y coordinates of the Pac-Man. They are interested in a variable inside of the class, in a value in the class, information inside of the class. We're talking about this guy here, have information that other classes need. The Pac-Man have the X and Y. The ghost, they want to know that information. I described the example with the video game. However, if you have a problem like this, something like a graphical user interface showing you data. Every single time that you use a program and that program is showing you a plot, a chart, any graphical representation of data, to be clear, the data is usually in one class, the class that have the data and process the data, whatever. And there is another class that is your graphical user interface. Another class that is the one that have the colors and the draws and all the fancy things. And these two classes, the graphical user interface need the data from the other class. It's going to observe the data there, just like the ghost and the Pac-Man. Another example similar to this one. Every single time that you do a program in Java, every single time that you create a graphical user interface and you put in that graphical user interface widgets, labels, or the classical. What do you do to know when one of these elements receive an event? What do you do when you want to do something when the user click in a particular widget in Java? Do you remember? Did you found the relationship here? Listener, observer. Let me be clear. It's exactly the same idea. The only thing that happened is Java used that name, listener, for the graphical elements. The idea is exactly the same. You have a class and you have an object from that class in your graphical user interface, and something happened with this class. Is up or down, is down when someone click. And you want another class to check if do this one, someone click it. And what you define is you add a listener. And if you remember, you add a listener, you pass a parameter here. What you pass as a parameter there is an object, the object that you want to observe this particular guy there. If you review your Java programs, every single time that you create a glabel, JBottom to this object, you do dot add action listener, maybe, parentheses, and inside of the parentheses, another object. What you are doing is to define a listener. What you are doing is to define this object, the parameter, to observe the widget. The listeners in Java are the implementation of the observer pattern. The observer pattern is the general solution for two classes in which the objects from one class need access to the information inside of the objects from the other class. The programming for the Pac-Man, for these graphical user interfaces, or for widgets and events, it's the same. One class needs to observe the other. The problem is clear. I need information from another class. Now, if the problem is clear, the important thing here is that problem have a solution. This is the solution. It's a class diagram. Okay. Details. Yeah. Easy. Number one, when you have a pattern, the pattern is going to give you a diagram, and the diagram is like a template. The template uses names, but those are the names that are generic in the template, and you need to customize for the particular problem that you are solving. For instance, I have this class diagram. How many classes do I have here? Just to be sure that we understand the diagram. How many classes do I have? Do we understand that these two, the one that I put the X, they are comments? So we really have, yes, thank you. We really have four things that are classes or interfaces. We're going to talk about it, but we have four. Moreover, we understand the connections between the classes. We have two inheritance and we have two associations. When you have this picture, class, 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 inheritance, inheritance, and associations. We're going to talk about the directions later. But when you have that picture, what you have is an observer pattern working. That is the observer pattern. If you have something like this in a diagram, in a big one, it's just like, okay, something is happening here between this class and this class. The two classes below, those two are the important ones. One is the one observing. Like this one can be my class ghost. In the pattern is ConcreteObserver for the template. If I want to solve this problem in my domain, my observer, my class, the one that is going to need information from another class, is the ghost. That is the guy observing. What about the ConcreteSubject? We're going to call subject. Later, we're going to call it observable to the element that is being observed, to the element that have the information. That guy is the Pacman. So I have the ghost and the Pacman. It's easy to remember, right? The ghost is the one that is observing, and the Pacman is the one that have the information that is important, the X and Y coordinates. And the only thing that I am going to do is, number one, separate what the Pacman and the ghost do as their responsibilities and the new things that I need to put on them because I want them to be subject and observer. They are going to have new things, but those new things are not going to be inside of the class. Those new things are going to be in another class. In particular, those new things are going to be in classes that I am going to use as the parents for my Pacman and my ghost. A definition in the patterns, you are going to notice we're going to use inheritance a lot. Why? Because we do not put responsibilities in the same class. We encapsulate responsibilities in different class. And if we want this guy here to have the responsibilities of this class and new ones, we connect this with inheritance. The child can do whatever the parent do and more. When I put subject as the parent of the Pacman can be a subject. The Pacman can be observed. And the Pacman can do more. The ghost, I am giving the ghost a new parent. The parent is observer. The ghost is going to have the skills to observe another class. And it's going to have the methods and variables that the ghost needs to be a ghost. The connections. These two are going to be connected. and these two are going to be connected. In the original pattern, the connections are directional. In the original pattern, you are going to notice this arrow, arrow. In the Java implementation, we are going to notice that the arrows disappear. In the Java implementation, we are going to notice that the connections are bidirectional, but that is a different story. So what information do we have in the parents? What do we do to implement this idea of one class having information to share and another class accessing that information? Easy. Number one, if you are going to be an observer, like the ghost, something that you need to have is a particular method that the guy that has the information can call to give you the data. Again, if you want to be an observer, what you need to have is a method that someone else can call to share you the data. Do you remember the name of that method for the listeners? Guys, if we do this for this scenario, this class observer for the listeners could be, for instance, action listener. Instead of observer, listener, and in particular, action listener. And this method that you need to have in order for someone else to tell you that something happened is the method action perform. For our observer, the name of the method is use update. And what do you do when you want to use listeners? Inheritance. In particular, with the listeners, you do realization. The general pattern is use inheritance between classes. For the listeners, this guy is an interface. This class, your class, whatever is your class, is going to do an override of this method action perform, right? And it's exactly the same that my ConcreteObserver, my host, is going to do when I implement these classes. I have an update here, and therefore the host is going to have a method update. Mandatory. If I have a parent class, I have a child, the child is going to inherit that method, and the child can override the method. For sure, the full family, the childs of observer, just like the childs of action listener, they are going to have that method. And with that, someone else can call that method in the same way that when you use listeners, someone is going to call the action perform. You do not really care who is going to call the method, but the method is going to be called when something happens with the widget or with the object that you are observing. Okay, that is the observer. What happened with the subject? You are students. As a student, you want to observe your professor. As a student, you are going to have a method update. The professor, the object that you are observing, is going to call your method update every time that something important happens. I am an object professor. I am going to call your method update whenever I want to share with you some information. What I need to do is to call the method update, but the update of which objects? The objects that are observing me. And which are those objects? In some point, I need to know who is observing me. In some point, I need to tell the subject, you have these methods, these objects interested in you. If you remember, in Java, for your listeners, you can have a button, B1, new whatever, and you do something like this. In that instruction, you are telling B1, the professor, that you have an observer, and that observer is this class. You are making the connection. What do you think the professor, the widget, the Pac-Man need to do when you tell that subject that someone else is observing? Very easy. I need to remember. I need to remember that I have 1, 2, 3, 4, 5 other objects looking at me. Because I need to remember that they are observing, and therefore, when I do something important, I need to notify them. In terms of programming, what do you do to remember those objects? You store those objects in a data structure, for instance, in a linked list or in an array. And if you have a linked list or an array to store a reference to the other objects that are observing you, well, if you have a data structure, I am pretty sure that you are going to have methods to add elements to the data structure, to remove elements for that data structure, and for sure, you're going to have a method to read the data structure. And if I am going to read the data structure, what about reading all the objects that I know are observing me, and for all of them, calling their method update? As a subject, as a Pac-Man, or as a professor, I do two things. I am here and I am waiting for someone to tell me, add me as an observer, add me as an observer. Every time that I receive an add, I put that reference into my memory, my data structure, a linked list. Obviously, someone can tell me, remove me. I don't care more about you. Add or remove. In some point, I can notify the people, the objects that are observing me, that something happened. Use with a loop and calling the method update. And I am sure that they have a method update because it's part of the pattern. I have a reference to the objects and I know exactly which method to call. I know exactly how to communicate with them because there is this template defining what they had and what I have, what they do and what I do. This idea work with the student and professor, Pac-Man and Ghost, the listeners. From the idea to the class diagram and the methods, You are waiting for the source code. Source code. Remember, observer, subject, and the concrete ones, the Pac-Man and the ghost. Observer. Do we understand this? Why do we want an abstract class with a method update that do not have a body? Is this useful for something? What is the goal of this? Polymorphic behavior, correct. This guy, this class, is empty. But what is going to happen when I do inheritance from that class and I have the ghost? Or I have a student? Or I have whatever. What is going to happen with this class ghost and this class student and this other class whatever? If they are doing inheritance from this one, they can override this method. They should have this method. I can be sure that if I apply inheritance from any class and I put this guy as a parent, all the family have the method update. Mandatory. If you do not have a method update and you do not provide a body for this method, your program do not compile. You have the responsibility to have the method and provide a body. That is exactly what happened when you work with listeners, when you do the implement, whatever listener you want. When you do that implement, when you inherit from that interface, you commit your source code to have the particular method action perform, or mouse something, or key press, the methods that correspond to the listener. In the global scenario, the method update for the observer pattern. Being sure that the childs are going to have the method. That is the only thing that this guy is doing. Moreover, think about the diagram. If I show you a diagram and I am showing you this class called observer, and I am showing you inheritance from a class X, you know that this class X, according with the pattern, and just because you are reading this observer as the parent, you know that that class X is going to be using information from another class. Which one? I do not know. We need to continue reading. But that guy X, all the objects from the class X are going to do something with information that they do not know, they do not have inside, but it's going to come from another class that this X is observing. Okay, observer, easy. The childs. ConcreteObserver, and remember, I am using as an example. So you can think about, I am doing the class ghost, I am doing the ConcreteObserver, I am doing one of the childs of observer. And you know what? The only thing that I need to do in the source code extend or implement. Extend if I have a class or an abstract class. Implement if you have this one to be an interface. Number one. Everything else all of that is whatever you need for the class. Whatever are the variables and the methods in your class, the variables and the methods for the problem that you are solving. All of that, the one that I put here, could be the methods and the variables that you already have in the class Ghost. Those are methods and variables that you need to solve the problem in Ghost or whatever you are doing. The only new thing is this and the method update. The method update in the parent, empty. In the child, you need to provide a body. A body. Whatever you want to do, but this method is going to be called when the information in the other class change. When the information in the other class somehow have a new value or the subject want to notify you, hey, I just did something new. That is the method that I am going to call. And inside, you can print a message or you can recover the information. Up to you. The Ghost, maybe the Ghost get the data and calculate the next movement in the Ghost because the movement of the Ghost is connected with the movement of the Pacman. That is the particular problem. The template is just give me the method and inside of the method do whatever you need. So far good. What about the subject? First, the parent. In the parent, as we defined before, number one, the main responsibility of the subject, or if you want, the observable, the thing that is being observed. What I need to do is to remember who is observing me. And in order to remember, what I need is a data structure. Maybe a linked list. A linked list of what? A linked list of observers. I need to remember the observers that I need to notify that I did something. Notice polymorphic behavior. Why the polymorphic behavior? Well, because my list is a list of observers. However, inside of the list, I am going to have ghosts or students or whatever I put as childs of observer. Polymorphic, my linked list. And if I have a linked list, what I can do is to add information in the list. In the original pattern, the name of the method is for the listeners. Add observer. And if you think about it, add observer looks like a little bit more descriptive. Add what? An observer to my linked list of observers. Similar to the other one, in the original pattern, attach the name in Java, remove observer. And the last one, a method notify. My method notify, a loop. And what I do in that loop, for every single element in this list, call the method update. That is the only thing that the subjects, the observables do. Add, remove, notify. Okay, that is the parent. What about the sub? This one, the concrete. This one is the Pacman. The Pacman is the one being observed by the ghost. What I want to do with the Pacman, number one, I am going to extend this class. Inheritance. In one class, I have the data structure, the method to add, to remove, and also the notification, the iteration on the data structure, all of that in one class. In the other class, the Pacman, I have everything that the Pacman do. All these methods, all these variables are used whatever you have in the Pacman already. There is nothing new here. The only thing that I need to do with the Pacman is this line. The only different thing. By doing that extent, what I am doing is adding to the Pacman a new data structure and 3 new methods. I have them in separate classes. I apply inheritance, and this class have whatever this class has before, plus whatever inherit from the parent. A new data structure and 3 new methods. I have my new ghost and my new Pacman. My new Pacman is a subject. My new ghost are observers. The only thing that I need to do now is to connect them. Connect them in a main. What is happening in the main? And I want you to notice how easy this could be. Number one, here, just imagine that what I am doing is to create a new Pacman. That line is Pacman is equal to new Pacman, an object from the class. And then step number 2, these ones. I am creating 2 ghosts, and they are new ghost. I have a new Pacman and 2 ghosts. You already have that. However, now in this version, this Pacman is a subject, and these 2 ghosts are following the observer pattern. The Pacman and the ghost, and I want to connect them. And in order to connect them, I have my Pacman object dot add observer the Pacman have 2 observers, G1 and G2. The classes connected with parents, the main, the objects, and I am just connecting the objects as you have the information and they are interested in your information. When I call the method notify that I have in the Pacman, in S, what is going to happen is this notify is going to send information to the method update in the ghosts. Obviously, I need to be careful where I put this instruction. I just put the instruction here in the main for the example. But this is the full description of how to solve the problem of sharing information between 2 classes. Obviously, what I did here is to implement everything from scratch. You do not do that. What you do is use libraries. The only thing that you need to be concerned is your class Pacman and your class Ghost. But the observable subject or the observer interface, that is something that you can get from the library. I am going to show you another example. if you compare this with any example using listeners, I am pretty sure that you are going to notice the similarities. Again, listeners, observers, a common problem, a common solution, clear. Like what? Yeah. Answering the question in the chat, yes, that could happen. I am going to show you another example like that. Yes. The only thing that could break the pattern, the only thing that you need to be careful is the following. You are going to notice several different versions of the patterns. However, always, 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 these two should be inheritance. Inheritance, realization, or generalization specialization. It doesn't matter if one of these or both are with dots, with dashed lines. It doesn't matter if these ones are classes or interfaces. So this is inheritance. Always is going to be the triangle in white. The lines could be solid or not. That is fine. And second, always, 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 the connection between this and this are going to be association with a direction or without the direction, but it's going to be association. Never, never, never diamonds involved in this pattern. That is kind of the key ideas here. Now, this first example, hopefully easy. Let's review what happened with Java. Things that you can do in Java beside the listeners to use the pattern. Quickly. I have a problem. I need you to define a class student, and I need you to create a class tutor, professor. And these two objects live in a classroom. There is a classroom. The classroom has a professor. The classroom has students. And you know what? Professor and students, they are observing. Probably, hopefully, the students are observing the tutor, or maybe the opposite, the tutor observing the students. But there is going to be a relationship of the observer pattern. Some of them have information that the other need. If I share with you this scenario, hopefully by now, you know how to solve this. What is the class diagram and therefore the source code that better match the description of the problem that I just shared? Number one, hopefully we agree that we are talking about a class student, a class classroom, and a class tutor. One class per element in the scenario. Number two, what is the relationship between classroom and student, between classroom and tutor? Composition, aggregation, or can we do use association? According with the things that we have reviewed before, the best solution that we can provide is only association. Remember, if we can avoid using diamonds, that is better. And you know what? So far, just because the description that you give me, what I am assuming is you want to have a classroom, and inside of the classroom that I could make the principal class, you are going to have the main method. I am not going to put all the details, but this is a public static void main and so on. And inside of the main, you can have something like that. The main, inside of the main, a student or more, a tutor or more, and you put the news there. And if you do that, local variables association, classroom associated with student and tutor. Next, I want the student and tutor to share information. In particular, the tutor is going to be the one having the information, and the student is going to be the one doing something with that information. You can do several different things to share information between the student and the tutor. If I give you the freedom, I am sure that you can do aggregations, composition, bidirectional associations. You can do several different things, several different solutions. Maybe some of them are going to be better than the pattern. Others are not. The problem is random. Whether or not your solution is going to be good depends on your experience. Whether or not your solution is better than the pattern, we do not know. Moreover, maybe other people is going to understand your solution, maybe not. If you follow the pattern and you use inheritance and you just make student inherit from observer and tutor inherit from observable, if I give you this class diagram, the yellow boxes, you are going to identify that we're using the pattern that I just explained to you. Not only you, but every single software developer is going to notice that the pattern is being used. Moreover, you are going to understand that something is happening between tutor and student, and you're going to understand that the student is observing the tutor. You're going to know that in this particular problem, the class tutor, whatever that class is, has information, variables, in which the objects from the class student are interested. Do you remember that the best source code is the source code that do not need comments? Do you remember that the best way to make your code easy to read is easy to understand just by reading the source code? Exactly the same apply with the class diagrams. When you read observer and observable, they are not comments. They are part of the pattern that I just showed you. But also, they are telling you what is going to happen between a student and tutor. Observer needs an update method, and observable is going to have this add, notify, and others methods. Good news, these two classes, the observer and observable, they are available in Java, in the Java API. You can use those packages, Java util, and you have inside Java util observable. In the original pattern is subject. In Java is called observable. And the other one, Java util observer, exactly the same that the one that we described for the pattern. Observer and observable. One is a class, the other is an interface. Student and tutor. As a homework, please, can you review this source code, and the method main that put everything together? Hopefully you understand the source code according with the previous example, but we can review this in our next lecture. Is the implementation of the observer pattern using the Java libraries. Any question, guys? Okay, so remember, you have a quiz. It's going to open right now. You have all day until midnight. Please complete your quiz today and review this. See you next lecture. Thank you.